Hello everyone, welcome back. In this video we'll go and analyze malicious Word document. So let's start by inspecting it inside an X editor, and we see that we have the D0CF magic number, which is the magic number for a Word.doc file. If it were a docx file, we're using the PK magic number. Yeah, so now we can go and try to open up it as an archive. And if we go to this folder, we have this macros and actually VBA, and yeah, so as we can see, this is a file weaponized with VBA macro. It can be potentially also legitimate, but in this case, it's actually malicious. Now, let's use a tool called only VBA. Let's go to the desktop, only VBA, and agreement. We'll basically take the macro code inside and analyze it. So it actually found that some suspicious code is actually used here, and there is what's called an auto execution mechanism with the auto open command to actually execute the malicious VBA macro inside. And basically this is the extracted code. You can actually go and use oledump to dump this code. Oledump and agreement, and we see that the actual code is in stream 8, which is with the uppercase M. So basically it indicates for us that this code is actually is an actual executed code, because lowercase m, it's a VBA macro code, but it's not actually executed. So let's do oledump -v for decompression, -s for string number 8, agreement, and let's output it to 8.bin.txt. And basically we extracted the code, so we can open it up in Visual Studio Code. And select the VB language. I can go and analyze the code. So basically it's kind of straightforward. We see that Windows API functions, or 4 Windows API functions to be exact, are imported from the kernel 32 DLL. And basically it is checking whether it's VBA 7, and if it's not VBA 7, then it basically imports the Windows API functions. So basically it's for versions, so it checks if it's VBA 7, and for the other VBA 7 versions, it basically does the same. So basically it calls or it renames all of those functions and gives them some kind of what's it called naming. So whenever you see create stuff used in the code, it will basically call create remote thread. So it's like a nickname for the create remote thread, and alloc stuff will use virtual alloc. So if you actually take create stuff, you'll see that create stuff is actually using the parameters of create process, which is 1, 2, 3, 4, 5, 6, 7. 7 parameters for create remote thread, virtual alloc, which is for alloc stuff. And basically you can see that basically from what we see here, it seems like a process injection is made here. So there is actually a process created, a process, legitimate process of run DLL32 exe, and to this process actually new memory is allocated. This shellcode is injected, and then basically the create remote thread function is basically used in order to basically execute this shellcode. Okay, so this is regarding using oledump to extract code. So we can basically close it up, and if we double click on it, you can actually go here into view macros, and do edit on the auto open, and we can see the same code here. And we can go actually put some breakpoints and watch stuff like this. So we want to toggle a breakpoint, we can use F9. So let's put an F9 for run stuff, RWX page for alloc stuff, and create stuff. So, and also for the my array, and let's execute it. In order to execute it, we need to do actually enable macros. So, or enable content. Let me just use pros hacker before I actually do it. And just let me just exit it right away. And terminate tree, and then again agreement. Terminate tree. Let me go to view macros. Put a breakpoint here, and breakpoint will create stuff. I think it's enough. You can do also an RWX page, and yeah. So, and run stuff for the spawning of run DLL to exe. Do execute. So now basically hit the breakpoint here, and we can also do watch points. So we can go and do add watch, and add a watch here. Actually, so we can see each one of those variables with assigned values. So for example, we go debug here and do step over, and now my array actually has all of those, all the loaded shellcodes, and that way we can actually inspect values inside variables when we debug, VBA macros. So basically now what we'll do, go to pros hacker. So for now we don't see any child process created because we didn't get to the point of run stuff. So now let's do play. Now we're in the run stuff. So again, we don't see anything. Now if we do play again, now it's actually created the run DLL to exit with this as suspended. So if we go to general, we'll basically we'll see that basically and now suspended. If you go to threads, see that everything is suspended. So basically it was created with the create pros with the flag of flag number 4 in hexadecimal. So it's basically with this create suspended flag. And now if we basically go to the memory of this process, do refresh, we don't see something very interesting here. So now if we do play and go here and do refresh, now we're seeing new memory region was allocated with the read write execute for now. And basically also the function of write stuff is already executed. I didn't put a breakpoint on it, so it's already executed. So an allocated memory with RWX permissions and the write stuff, which is the write process memory function, actually was used to actually inject this shellcode. And we can even see some kind of an email here. Okay, so we can actually go and dump this shellcode dynamically, or we can even take this and put it into CyberChef and do some kind of decoding tricks statically and then write it to a file and stuff like this. And basically that's it for that. So if we now actually go and execute create stuff or create remote thread, we'll actually go and execute shellcode. Okay, so try to see if it tries to connect to some kind of place or do something. But basically, let's go cross explorer. So basically we have run the editor to exe process with injected code, which tries to basically, in the end of the day, it's a interpreter shellcode which will try to communicate back to some kind of a C2 server. So this is how you can inspect it dynamically. Now, if I want to decode it statically, in this case, I can just take this shellcode, go to CyberChef, and do from decimal, put it here. Now we have this problematic spaces here, so let's just remove them. Let's clean them up. So each one of those itsy bitsy parts, let's do Control H for replace, remove them all, and take the clean version and put it here. And the delimiter here is not space, actually comma, and support signed values, because actually you have two things. You have unsigned values, which can be only regular numbers like 10, 40, 56, 5, 7. It can be what's so called positive number, and signed values can be either positive values like 10, 12, etc., or negative values like -4, -5, etc. So in this case you see negative values, so that's why you need to take the support sign values. So now if you take and copy it, copy this, well, so now for now it seems like gibberish, but you see there is some kind of string here. So if you copy it, or before we actually copy it, you can validate it by do hex, and now you can actually see this FC-E8 seems like a normal assembly opcode. So if we go to process hacker and run the alternative to exe, which still is running, and RWX, see that is the same opcode as you see here. You can go and do even disassemble x86 if you want to extra validate it and see that it actually translates to logical assembly instructions. So basically you can take this hexadecimal values like this and go to desktop, and basically or just just take it hxd, create a file like this, paste it like this, save it, code.min, and you have the shellcode. And you can try to analyze it in different ways. You can even use tools like shellcode to exe and then put it in IDA and stuff like this. So thank you very much. See you in the next videos.